Hi. I just realized that the previous video that I recorded and posted regarding sigma notation, it doesn't have an audio, so I'm just gonna go through the content of that video in this video so that you get to hear what I was actually trying to say when I was recording that video. Nonetheless, I'm not gonna delete that video. This one is gonna be shorter than that video on its own. It is actually the previous video, it was 19 minutes longer, so I'm hoping this one I can make it even a bit shorter. So with sigma notation, just to get straight to the point, sigma notation, when they say represent a series in sigma notation, what I was trying to say to you is that we have what we call a series and we have what we call a sequence. The difference is with that in series we have a plus, we use the actual signs, which is plus. Sometimes it will be a minus somewhere there. You will see in the other examples. So we basically add them. A series is just the arithmetic sum. By arithmetic sum, meaning you add the terms of the sequence considering the signs. If it's negative, you put a negative. If it's positive, you put it a positive, like that. However, in this first example, the series that is given, all terms of the series are positive. All terms of the sequence are positive. When you add them together or getting the arithmetic sum, that means you're only going to be having positive signs. That's what we call a series, just adding the terms of the sequence. Remember, before that we were doing basically we're being introduced to the sum formula or the series formula. The sum formula, what it does is just a shortened way of adding the terms of a sequence. For instance, in this case, suppose you have 1, 3, 5, 7. This is an arithmetic sequence, or a linear sequence rather. Depending on which term you prefer, linear or arithmetic, they still mean the same thing. So if they give you these terms and they ask you, can you get the sum of all these terms? You are basically just going to do this, add all of them to get the sum of all the terms. But if they keep including more terms all the way to infinity or whatever value they'll eventually get to, they keep asking you to add them. Sometimes they'll get to 39 as the series suggests there. You keep adding them. You see that it becomes a bit impractical for you to be able to add all the terms and just type them on a calculator. Maybe not necessarily impractical, but it's time consuming. So we introduced the SN formula to calculate that. So for an arithmetic, we had two types of SN formula, which we call the sum formula or the series formula, which was n over 2 into brackets 2a plus n minus 1 d. We could also use the one for infinity, not necessarily infinity, the one for which is this one basically. When we know the last term, it's n over 2 a plus the last term. So we could either use this one, and then I also introduced you to the other sum formula or the series formula for a geometric series, which were like this: Sn equals to a into r exponent n minus 1 all over r minus 1. You could also use the other one, a into r exponent n minus 1 over r minus 1. Remember that with these two formulas, r cannot be equals to 1, but the two formulas, they do the same thing. They are the same, or rather similar. All you need to do is just to pick one of the two formulas when you're getting the sum of the first n terms. Remember also, the n on the Sn formula, it does not stand for the position. Rather, it stands for, or it does not necessarily stand for position of the last term. What it stands for, or rather it stands for how many terms you are adding. And how you get n is by saying n equals to top minus bottom plus 1. That's how you calculate n. But in the Tn formula, which we started with at the beginning in the first video, for a arithmetic series, it's what is it? It's a plus n minus 1 d. That's the formula. This n, it stands for the position of each term, and Tn on its own is the value of the term. So just keep that one in mind. Now, what I wanted to explain here is that when you have a series like that, you are trying to get the sum of all the terms. You can either use that formula, this one, that one, or if it's depending on whether it's a geometric or an arithmetic. For and geometric, you could also use this one for when you're getting the sum to infinity, just adding all the terms up to infinity. You could use this one for a geometric series. So with sigma notation basically is just a way of representing this series. It's like a shortened way of representing the whole series. Instead of writing the numbers down like this, saying 1 plus 3 plus 5 plus 7 all the way to 39, you can represent them in a very shortened way. If you look at it, we are given an example here. We're going to look at a few examples of how we can actually do that, because trying to write a series like this, it just takes forever. So we have a shortened way of doing it. So looking at this example, write the series in sigma notation. They give us a series like that. As I've explained, because of the plus signs, we call it a series, not a sequence. So what you can do, because you are very familiar with a sequence, you can rewrite the first three terms as a sequence and be able to conclude or calculate the difference between every two terms. Try to see if they are common. If they are common, then you can conclude that you actually have a arithmetic or a linear sequence. Then you can use this formula to get the general term or the general equation for the sequence or the series of an arithmetic pattern. So we did exactly that. We know our A is the first term. As usual, it didn't change. It's still the first term. Once we know that the A is the first term, which is 1 in this case, we know the D is 2. Then we just substitute for A and D. Then we simplify, we get our Tn formula. From there, okay, maybe before I proceed, one thing I need to look at is to explain this part. The top part that I just wrote there, of what I mean by sigma notation. I did just say now that it's basically the shortened way of representing a series. So all you need to do is to get do this sign is the sigma sign, and then you get the general formula. You put it in brackets like that. You start with n equals to the b. B is for, what is it, this bottom, the T for top. When you calculate n, that's what you're going to use, plus 1 for the Sn formula, of course, up till T. So when they say representing sigma notation, they basically mean just do this. Write the series in this form. So all you need to do is to firstly get the general term, and then this will be your position of the last term, which is usually called top, and then this is position of the first term, like that B there is the position of the first term, T is the position of the last term. So all you need to do now on the equation or the question that we are given, get the Tn. We got the Tn, we just did that. There we are. At least now we have the first thing that we need to do for us to write the series in sigma notation. Now we need the T and the B, then we are good to go. We can represent it in that format. To get the T, or maybe the B even, B, because the position of the first term according to the series, that is the first term. 1 is the first term. So the position of the first term is basically 1. And then position of the last term in this case is 39. So what is the position of that 39? So we know, remember from the beginning when we were using the general term equation, we'll just say 39 equals to the Tn equation like that, and then we solve for n. That gives us the position of the last term, that is 20. Then now we just need to write it in this sigma notation format or sigma format. That's basically what you do, and then you are good to go. Just need to write it like that, and then that's it, you're good to go. There's really nothing hectic about sigma notation. That's basically what you are required to do. With sigma notation, if you are required to evaluate this or get the value of the sigma notation, or what the series which is represented in sigma notation rather, being asked to determine it or evaluate it, you are basically going to say it's equals to Sn. Because Sn, you have a formula for Sn that you could use, and it's quicker to get the sum of all the terms that are represented by this sigma notation. So all you need to do is just to use the Sn formula, know which Sn formula to pick between the 3 or 5 of them, and then you should be fine. You pick based on the Tn formula that you have here. If it's a arithmetic, you need to pick an arithmetic equation. If the formula that you have there, it's a geometric one, you need to pick a geometric Sn equation. But always remember, in the Sn formula, the n is top minus bottom plus 1. Okay, we're just going to be looking at the second example now. In the second example, you're also given a series, but the series is actually a geometric series. Sometimes you're not told that it's a geometric series or an arithmetic series. What you need to do always is to try to just write the first 3 terms of the series as a sequence, and then you work with the sequence to determine whether or not this is a geometric series or an arithmetic sequence, or a geometric series, sequence, or an arithmetic sequence rather. So for us to check if it's an arithmetic sequence, what we will do is say 6 minus 2, we get a value which is 4. 18 minus 6, we get a value which is definitely not 4. Therefore, we know that this is definitely not an arithmetic sequence. Rather, we can try now to check if it's a geometric sequence. Checking if it's a geometric sequence, we just divide 6 divided by 2, we get 3. 18 divided by 6, we get 3 again. Therefore, we have a common ratio, which therefore means we have the geometric sequence. So if it's a geometric sequence and we're trying to just represent it in sigma notation, we know that to represent this in sigma notation, we need the general term like that, so that we can write it in this format. We need the general term, we need the b, we need the t. T being the position of the first term, no, the last term I mean, and then b being the position of the first term. So in this sequence or series, we already know that the first term is 2 and its position is 1, and we know that b is therefore equals to 1. That one we are okay with it. We know that b is equals to 1, we don't have a problem. The last term, it's actually 1 3 1 2 2. We also need to get the position of that, but before that, for us to be able to get the position of the last term, we actually need the general term. So we will try to start with the general term. So because it's geometric series, that's the equation that we are going to use to get the general term. And on that equation, our a is 2, which is the first term, and then our r is 3, the common ratio. Now that we have the common ratio and the first term, we know what our general equation is. Now that we know what our general equation is, for us to get the position of the last term, we equate the last term to the general equation or the general term. Once we do that, we just now need to simplify and solve for n on that equation. We solve for n, then we know that the position of the last term, it's actually 9. That means our t is 9. So now we can just rewrite this thing in sigma notation, then we are done, good to go. Moving on, suppose they give you this on C, they say determine sigma notation. Basically, all they ask you is determine this. They don't even tell you that this is equals to Sn. They just ask you to determine this expression. It's an expression like that. However, if you refer back to the presentation that I make, I was saying the sigma notation, it's equals to Sn. So you could use the Sn to evaluate or determine the sigma expression rather. So basically the sigma, which is this sigma, it just means sum of all terms of this equation, which is in brackets, from k equals to 4 until k equals to 13. That's basically what it means. So now what you need to do, just expand this whole thing, which is what I did as the first step, when you expand the sigma notation, you are representing it as a sequence because you are used or more familiar with working with sequences. Then it makes your life simple when you have a sequence. So we're just going to substitute k by 4, and then we keep increasing it by increments of 1 to get the first 3 terms. So by that, I mean, at first you substitute 4 in the place of k in that equation that you have in the brackets. After that, you add 1 to the 4. You have 5. Now you get the second term. Now you add, from 5, you add 1 again, which now gives you 6. Then you get the third term. Now that you have the first 3 terms, you just need to subtract between the 2 terms, every 2 consecutive terms, and see if you are getting a constant difference or a common difference. Definitely you are getting a common difference because in the brackets you have a linear equation or a linear expression, an arithmetic expression rather. That's what you have. So you know that this represents the Tn in the brackets. So if the Tn is equals to 2, basically it will be 2k since they're using k there. So whether they're using k or n, it really doesn't make that much difference. Side. So you just need to understand the k is just a variable which represents the position of a term in this case. So you don't need to stress your head about it. Sometimes they can use k, sometimes they can use p, whatever letter they feel like using. It's still fine. They still mean the same thing. Just remember what it means. Yeah. Moving on, now that you have all the 3 terms and you know that this is an arithmetic sequence, the sigma notation, it represents an arithmetic sequence or arithmetic series rather, not a sequence but a series, because of the sigma means sum, so it means it represents an arithmetic series. So it has already been represented for you or presented to you in arithmetic notation. So all you need to know now is to remember from the previous, before you get here you had a series, before you get to the sigma notation you had a series. So here now they already had the series, they are giving you the sigma notation. All that you need to do is to expand it, get the first 3 terms like I said by substituting from the bottom, which is b, and then increasing by increments of 1 to get the next 2 terms. Now that you have the next 2 terms, you have your a and your d, then your n is still top minus bottom plus 1, as I've explained previously. Now that you have your n, all that you need to do now is to see how you can evaluate that. You can evaluate that by using the SN formula. With the SN formula, there are different SN formulas that you could pick from, like I said previously. So because in the brackets you have an arithmetic expression, you're going to need to use an arithmetic sum formula. You have different formulas to pick from, this one and that one. Usually this one you need to know what your last term is and then what your first term is. In this case, we do know what our last term is. Okay, where were we? We were here. Do we know? To get our last term, we'll need to substitute 13 and we can get our last term. Then we can use the SN formula. But to solve this one, I use the first formula because it's also applicable. So using the first formula, what did I do? I just said, basically I just substituted a, I substituted d, what is n? N is 10, then I was able to get my 100. So if maybe you can try to use the last formula like that, a plus l. So what is our a? What is our n? Sum of the first 10 terms. So basically here you're going to substitute n equals to 10 over 2. The first term, a, is going to be which term? That's going to be 1. The last term is actually going to be what is it? We need to substitute 13 to get the last term. Do we have the last term? That's just a lot of admin. So that's pretty much the reason why I didn't use this one. But you can get the last term by saying 2 into 13 minus 7. Let me just quickly do that and see how much I'm getting. 2 times 13 minus 7, I get 19. So 19 there. Okay, now just punching everything on the calculator. I have 20 in the brackets, then it still gives me 100. You see, so you could use either one of the two formulas, and then you should still be fine. Okay, moving on. Suppose you're being asked now, determine this expression. It's a similar question to the one that we just had, but in the bracket, the only main difference is with the formula. Now you have, the expression in the brackets, it's more of a geometric than it is an arithmetic. So it's definitely not an arithmetic. Arithmetic, you cannot have an exponent. So this is definitely geometric. You can tell from the get-go. However, you still need to know what your A is. Sorry for that. You still need to know what your A is, what your R is. So what you will do, as you have done in the previous question, you still expand this thing, the sigma expression or notation. Sigma expression rather, I think it makes more English sense. So just expand it. First you substitute the B, and then you keep adding 1 to the B to get to the next term. Just get the first 3 terms. That's enough for you to see which pattern it is. Once you have expressed it like that, just simplify. Then you have your first term, second term, third term, and keep dividing every 2 consecutive terms, and then you get the common ratio. That means your R is 3, your A is 2. Now that you know your R is 3 and your A is 2, you have been asked to determine or that expression there. You're going to use the SN formula, because expanding this whole thing and adding all the terms together, it's just time consuming. Like remember when we're using the SN formula, they will give you a series of numbers or terms rather. Then you just have to use the SN formula to add them. So now the fact that they give you a sigma expression, expanding them, you're going back to what you were trying to solve by using the SN equation. So if you expand them and try to add them on a calculator, that still takes a lot of your time. So rather, just expand it for the first 3 terms, and then those 3 terms, they will give you the important parameters that you need, which is usually your A and your R. And then you also get to know which SN formula you could use to actually evaluate the sum of whatever number of terms you are required to calculate. But it's always the number of terms that you need to calculate. It's top minus bottom plus 1. So from here we already know that our top is 7, our bottom is -2, and then we get our value of n. Now that we have our value of n, we know that the whole expression is actually equals to Sn. Which Sn are we going to use? We're going to use the geometric Sn formula, which is the sum or the series formula. By Sn, I just mean the sum or the series formula. Then just substitute your A, you know it's 2, your R is 3 in this case, and then your N is 10, then you are done. You're good to go. That's basically the evaluation or you determining that expression that you were given. Okay, moving on with E. I hope you really understand what I've done so far. Moving on with E, but if you don't understand, you can always post your questions or your confusions in the comment section. Then I will see if I can maybe come up with a better way of explaining the content so that everyone can be able to understand. Moving on nonetheless, assuming everyone understands so far. Determine the value of x if this sigma notation or sigma expression it's equals to 100. So like I've been saying, to evaluate the sigma expression, you just need to use a SN formula, the relevant one, the applicable one, depending on what you have inside the brackets. Now they already gave you what it is equals to. So the only difference of this question to the previous question is that instead of evaluating it, or instead of you being asked to evaluate the expression, they've done the evaluation for you. They've used the SN formula for you. Now they just left this top, the T that we have been putting there when we're writing this thing in sigma notation. So we're still going to follow the same procedure. The only unknown variable is just going to be that T. In this case, the T is X that you're being asked to solve for. So you just need to relax, expand this thing as usual. We've been doing in the previous questions. Expand the what you call the sigma expression rather, or the Tn inside the brackets there. So you put 4 first, and then you keep increasing by increments of 1 like you did previously, and then now you know what your A is. The A is 1, your D is 2, because in the brackets we have arithmetic expression. That's why we'll have an A and a D. So now that we know what our A is and what our D is, we just need to know Sn formula that we could apply, because we can try to say we need n before we substitute in our Sn formula, but n, remember, is top, which is x in this case, minus bottom, which is 4, plus 1. We don't know what our x is, so we cannot get n. However, if we just substitute everything like we would do on an Sn equation, what we will see is that we have all the variables besides n. So once we solve for n from here, we can put it there and then be able to solve for x, which is what our question is asking us to do. So that's basically what I did. I substituted the Sn, the A, the D, and then I solved for n. After solving for n, I got to this point that n could either be plus minus 10, but we know that our n cannot be negative because it represents the number of terms that are being added together. So it cannot be negative. When you say you are adding terms, you can't say I'm adding negative 10 terms. That doesn't make English sense at all. So we will take the positive value of n and say n is actually equals to 10. So now that our n is 10, we go back to that part, top minus bottom plus 1, then we solve for x, then we are done. Moving on, we have a similar question here. It's just that now we have a geometric in the brackets, a geometric expression in the brackets, and then they also gave us the Sn. So that Sn, basically Sn is the evaluation, or when they were determining or evaluating rather this expression, they found that it's equals to 59048. They're just asking you to also determine x again. So just know that Sn, it represents the Sn of which series. Is it a geometric or an arithmetic? It's a geometric in this case because in the brackets we have a geometric expression. So we are going to be using this as our Sn formula, not the other one which we used in this case of an arithmetic series. So we are good to go. We still do the same thing. First step, expand the terms or the general term inside the brackets. You do that like that by substituting firstly again the bottom term, the bottom value, which is usually represented by b in my previous video. So we'll use b and t in my previous video, but now they're using what? They gave it the actual value of b. So you put b there, which is negative 2. Then you say negative 2 plus 1, it gives you negative 1. That's when you can now substitute to get the second term. Negative 1 plus 1, that is 0. That's what I substituted there. And then now I just simplify. You get 18, 6, and 2. So dividing to get a common ratio, because you are using a geometric series, you know what your r is, what your a is. So now that you know what your r is and your a is, come back to this equation, which is what I've done here, and then just substitute everything and realize that similar to what you had previously, the only unknown here is your n. So our n, remember, is still top minus bottom plus 1. By top, I mean this. By bottom, I mean that. B for bottom, T for top. That's why I was using T and B as the variables rather. So we will calculate n, but we can't do it from here. We just had to use the equation and calculate n first. After getting n, in this case we got that n is actually equals to 10. After getting n, this is what we had. Top minus bottom plus 1, then we could solve for x, then we were good to go. We didn't have much problem. So those were some of the interesting questions that I thought I was meant to share with you, so that you can be able to grasp this chapter or understand how to solve most of the questions regarding regarding sigma notation rather. So I think I'll stop here, because this was just to cover what I had already in the previous video, where I just forgot to activate the audio thing. So I hope it answers some of the questions that you might have had. We'll look at another parts a bit later after this. Thank you.